geometry class. Well, due to a series of unfortunate events, we are not having class this week or next week. So we're going to do everything by these videos and using the help page where you can go and put any questions that you have. And unfortunately, this is one of the most difficult chapters in the book and one of my favorite ones to teach. So strangely as it is, this is how it's going to be. So if you have any questions, you can go to the help board, which I put in that email, and ask questions. And please watch these videos. So here we go. 8.4, we're going to be working with special triangles. And I'm using a new forum to do these videos. I've had tons of technical problems today. It's taking me a couple hours to get to this point, but hopefully it will benefit you. So please watch these videos. So we're going to talk about special right triangles, which we have talked about in Algebra 2. So if you didn't have Algebra 2, these might be new to you. These are also on the SATs, so pay attention. An isosceles right triangle is also called a 45, 45, 90 triangle because the measures of the angles are 45, 45, 90. And there's a theorem. The theorem is theorem 8.6, which is the 45, 45, 90 degree theorem. It says, in a 45 degree, 45 degree, 90 degree triangle, the hypotenuse is the square root of 2 times as long as the leg. So it's hard to see this triangle. I took pictures out of the book so that I didn't have to type this all up. So I'm going to go to the side and explain what this 45 degree, 90 theorem is about. So here we go. On to the side. I'm going to draw a 45, 45, 90 degree triangle. Best of my ability, of course. So here we go. The sides are going to be the same. It's an isosceles triangle because the angles are the same. And there we go. So this is our 90 degree angle, and this is 45, and this is 45. So what the theorem says is that the hypotenuse is the side opposite the right angle. This is really important because we're going to be doing trig. We need to understand what the hypotenuse is. It's also the longest side in the triangle because it's opposite the longest angle. These sides are the same, so they're going to be exactly the same. Whatever one is, the other one is going to be also. So for instance, this side is 5. The hypotenuse is going to be 5 times the square root of 2. That's what the theorem says. It says the hypotenuse is the square root of 2 times the leg. In a right triangle, the sides that aren't the hypotenuse are called the legs. So in order to get the longer side, you take the leg times the square root of 2, and that's all there is to it. Now if you're going the other direction, let me just erase these numbers. Let's go the other direction real quick. If this side is 10, these sides are going to be, we're going to divide by the square root of 2 because they're going to be smaller. So you use division to get the smaller sides. You use multiplication to get the bigger side. So this side, both sides, are going to be 10 divided by the square root of 2. Of course, we don't leave it that way because it's not rationalized. So it's going to be 10 square root of 2. We rationalize by multiplying the numerator and the denominator by the square root of 2. We get 10 root 2 over 2. These cross out, and our final answer is 5 root 2 for both of the legs. So let's do the example that they have for us in the book. So it says, find the value of x. So in the first one, x is the hypotenuse. Now x is the hypotenuse. And we remember from our theorem, let me just slide this theorem up here, it says that the hypotenuse is the square root of 2 times the leg. The leg is 12. So the hypotenuse is 12, that's the leg, times the square root of 2. That is it. The second one, we're going the other direction. We have the hypotenuse. So the leg would just be 8 divided by the square root of 2. And then we rationalize. So if you're going from smaller to bigger, you multiply. Bigger to smaller, you divide. So it's going to be x equals 8 root 2 over 2. And we divide these out, and we're going to get equals 4 root 2. And that's it. So now we're going to move on to the more complicated one, which is the 30, 60, 90 degree triangle. The theorem 8.7 says, in a 30 degree, 60 degree, 90 degree triangle, the hypotenuse is twice as long as the shorter leg. And the longer leg is the square root of 3 times as long as the shorter leg. So it's really important we know which is the shorter leg. The shorter leg is always opposite the smallest angle. So in this 30, 60, 90 degree triangle, the shortest side would be the one opposite the 30, and we're going to call that one X. The hypotenuse is 2 times the shorter side. So we found the shorter side. The hypotenuse would be 2x. And the 60 degree angle is the square root of 3 times the shorter side. I put the x first just because so we can tell that it's not under the radical. So let's do an example with this type of problem. Oops, let me just erase that. Okay, that's because I did this video more than once. All right, it says find the values of x and y. So here we go. X, let's find the shortest side first. So here's 30 degrees. The shortest side is 6. So in order to find the hypotenuse, which is x, it's 2 times the shortest side. So it's going to be 2 times 6. It's going to be 12. 2 times the shortest side. To find y, which is the one opposite the 60 degree, it's the shortest side times the square root of 3. Whoops, I didn't find the, yeah, that's it. Okay, let's look at this next one. The next one, where we look to see where the shortest side is, and the shortest side is an unknown. So the only one we have is the one opposite the 60 degree. Now, if you had the shortest side, you would find the 60 degree side by taking it times the square root of 3. So we're going to go backwards. We're going to find the shortest side first, which is x, and we're going to take the 60 side, which is 8, and we're going to divide it by the square root of 3 this time. And then we have to rationalize, and we're going to get x equals 8 root 3 over 3. That's just the x side. Now to get the hypotenuse, that's the one opposite the 30 degree angle, the hypotenuse is 2 times, which is y actually, 2 times the shortest side. So it's going to be 2 times 8 root 3 over 3. So the hypotenuse is 16 root 3 over 3. So hopefully as we go through, I'm going to do the classroom exercises with you. Hopefully as we do more examples, this will become easier and easier. So here we go. Let's look at the classroom examples. This is right from your book, so you can get your book out and look at it if you want. So they start out easy and they get progressively harder. So the first one, we're talking the 45-40. They don't fill in everything. They make you think. This is the right angle here. So some of these we can do right on the paper. Other ones I'm going to have to pull to the side because they're more complicated. So this is a 45-45-90 triangle. So we know that it's an isosceles. So this side's going to be 6. They don't ask for that. And because it's 45-45-90, we know that it's going to be just the side, the leg, times the square root of 2. The 45-45-90s are a lot easier. You either multiply by the square root of 2 or you divide by the square root of 2. So here's another one. This is 45. We can subtract from 180 and figure that out, right? So we want to find, we're given the hypotenuse, we want to find a leg. Well, we're going from bigger to smaller, so we're going to divide. So we get 10 divided by the square root of 2, and we're going to have to we're going to take that times the square root. We're going to, excuse me, let's fix that. So we have the longer side is 10 root 2, and we're going to divide it by root 2 because we're going from big to small. So we divide by root 2, so x is just going to equal 10. All right, next one, we have the hypotenuse. We want to get a shorter side, so we divide by root 2. So it's going to be 12 divided by root 2. We need to rationalize. And we're going to get 12 root 2 over 2, which would be 6 root 2. Okay, I should have had you work those first before I did it. So why don't you pause it and see if you can do 4, 5, and 6. Those are the 30, 60, 90 degree triangles. So try those on your own and then start the video up. Okay, hopefully you listened to me. All right, here we go. So this is a 30, 60, 90 degree triangle. They start out easier. When you're having a 30, 60, 90 degree triangle, you find the smallest one. The hypotenuse is always 2 times the smallest side. The smallest side would be the 5 because it's opposite the 30 degree angle. So x is simply going to equal 2 times 5. X is going to equal 10. Told you they start out kind of easy here. Okay, now getting harder. The side opposite the smaller side we don't know, but we do know that the hypotenuse is 2 times it. So to go the other way, we're going to divide 13 by 2. So x is going to equal 13 divided by 2, or 6.5. So remember, when you're going from big to smaller, you divide. We know the hypotenuse is 2 times the smaller side, so we're going to divide by 2. Okay, this one's not quite as bad. We're given the smaller side, right? The side opposite the 60 is square root of 3 times the smaller side. So in this case, x is going to equal 3 root 3. All right, let's move on to these little bit harder ones. Now, this one, they expect you to use your geometry just a little bit. So this is a square. You can tell because all the sides are the same and you have a right angle here. So we know that if it's a square, the diagonal bisects the angle. So this is a 45, 45, 90 degree triangle. So this is your 45, this is your 45. You're given your hypotenuse, you need the legs, so you're going from bigger to smaller, so you're going to take 8 divided by the square root of 2. And you rationalize this. Sorry that I'm squeezing this all in here. And so we're going to get 8 root 2 over 2, which is 4 root 2. All right, this one, very similar until we get to these last 3 harder ones. So this one, we have to figure out what kind of triangle it is. If you look at it, it's a 20, 20, 20, which means it's equilateral. So if it's equilateral, then this is going to bisect the angle. They don't really give us enough information on this one. Yeah, they do. Because of bisect, we know it's a perpendicular bisector. So we know it's going to be perpendicular because they give us this 10 and 10. So since it's a 30, 60, 90 degree triangle, we know that this angle is going to be 30 because this is bisected. So that's going to be your 60. Ooh, it's going to get messy in there. Okay, we're given the hypotenuse. Actually, we're given the one opposite the 30. So the one opposite the 60 is the smaller one times the square root of 3. So it's going to be 10 root 3. That one wasn't so bad. You just have to remember that the side opposite the 60 is the smaller one times the square root of 3. Okay, now the next one, it does get a little bit harder. So I have some little extra drawing room over here that I can use. So here we go. We have two different kinds of triangles. If you look at the Slater, the answer is wrong. So Slater is not always right, but it is a helpful tool. So we know that this one's going to be 30 because we have 60 and 90. We're given the side opposite the 60 degree angle. So I'm going to do it a little bit different. I'm going to go and get the one opposite the 30. I think this is the fastest way to do it. So the one opposite the 30 is going to be the one opposite the 60 divided by the square root of 3. So bear with me here. So we're going to take 9 square root of 3, and we're going to divide it by the square root of 3. And that's going to tell us that this side is 9. I don't know if white's going to show up. It kind of does. So this side's going to be 9. Going from the 60 to the 30, you divide by the square root of 3. And then the hypotenuse is 2 times the one opposite the 30. So your hypotenuse is 18, which is the hypotenuse in this 45, 45, 90 degree triangle. So we have the hypotenuse, so we're going to divide by the square root of 2. So let's finish this one up. So we're going to get x equals, that's what we want, is the hypotenuse divided by the square root of 2. That's how you get the side, square root of 2 times the square root of 2. And we're going to get 18 root 2 over 2. And finally our answer is 9 root 2 for this number 9. All right, a little tricky. Hopefully you're tracking. Most of you should have learned this before, but I know it was probably hard to remember. Okay, let's hit these last 3 harder ones and close this lesson up. This one says in a regular hexagon, A, B, C, D, E, F, AB is 8. So we have AB is 8. That's right here. I'm going to have to draw this one on the side, I'm afraid, because it's just going to get really messy. We need to find PQ. No, we need to find AD, this line right here, and AC. So bear with me. You can try it yourself and then look back if you want to. So I'm going to redraw this over here. It's not going to be pretty, but we're going to give it a try. I think I'm just going to do it with a pencil without straight lines. So we have this, 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 it's 6-sided, this, 1, 2, 3, 4, 5, whoops, that's not going to work. Let's try it again. So 1, we don't have to be small about it, 2, 3, 4, 5, 6. And I think it went A, B, C, D, E, F. Now it's a regular hexagon, so we need to figure out how many degrees are in a regular hexagon. So do you remember that? You would figure out how many triangles there are, which is going to be 6 sides minus 2 times 180. So if you drew triangles in here, you would have 4 triangles. So we're going to take 4 times 180. And that's going to tell you how many degrees are in the entire thing, which is 720. Then we're going to take that and divide it by how many angles there are. And that's going to tell us that each of the angles are going to be 100 degrees. So the angles equals 120 degrees. Each one of these angles are 120. Now, they want us to find this line right here. I think I actually am going to use the line tool. I hope you're still with me. I feel like this is really boring, but I got to teach it. So here we go. All right, so those are the 2 lines we want to find. It's regular, so this is a bisector. So it's going to bisect. Each one of these angles is 120. So this is 120 right here. It's regular, so it's going to be an isosceles triangle. So that means this angle right here, if we subtract 120 from 80, we're going to get 60, and we have to share it between these 2 angles. So this is going to be 30. This whole angle right here is going to be 120, right? So 60 of it's going to be here, and 60 it's going to be these 2 angles. If this one's already 30, then the other angle is also going to be 30. So this is 30. Okay, Now this one's going to be bisected too, just like this 60 over here. So this one's going to be 60 because the angle is 120. And so that makes this one the right angle. Whew, it's a lot of work. Now, I don't know what the question is. I think they gave us some information. They told us that AB is equal to 8. So this is 8 right here. That is 8. So now we have to work our way around. We know that each side is 8, so we know that this side is 8. It's the one opposite the 30. So the one opposite the 90 is going to be 2 times that. So this is going to be 16. Finally, making it our way around. Now we also need this one. So the one opposite the 60 is the square root of 3 times the smallest one. So this one right here is going to be 8 root 3. So, whew, that's how you get that. That was a little tough. Okay, let's go back to the next one. You can always rewatch the video if you want to see that again. Okay, now this one is express P, Q, PS, and QR in terms of A. There is A. I'm going to try to just write this one right on the board. See how that goes. If I could make my pen a little bit smaller. Yeah, I think I can. Okay, so here we go. A is the side opposite the 30-degree angle. So the one opposite the 90 is just going to be 2 times A. Then they want us to know that's PQ. Then they want us to know PS. Well, PS is the one opposite the 60, which would be A times the square root of 3. This isn't so bad, right? And then they want us to know QR. QR is the hypotenuse of this triangle. Let's see, what do we know? We know that this is 90. Oh, we have a leg, and the leg, it would be square root of 2, A times the square root of 2. The leg times the square root of 2 is the hypotenuse. All right, whew, almost. Last one. If the measures of the angles of the triangle are in the ratio 1, 2, and 3, are the lengths of the sides the same ratio? Well, that is not going to be true. I'm going to show it really quickly. If we did a 30, 60, 90 degree triangle, let's just draw that right here. And we put because they would be in the ratio of 1, 2, and 3, because 1 would be the 30, 2 times that would be 60, and 3 times this would be 90. The sides would be 1, 2, root 3, not 1, 2, 3. So this answer is no. Okay, that was a long video. Thanks for listening, and I will have the video for lesson 8.5 shortly. Hold on while I try to figure out how to close this up.